All right, so we're going to look at the final category of common stresses that we come across when we're doing structural engineering, and this is bearing stress. Um, it's actually a type of direct stress, so it's very similar to an axial stress. And it occurs when you have, two elements come in contact with each other. So one example that we'll have is say that we have a, um, you know, two floor joists um, resting on each other. So you've got one here, and then we have one perpendicular to it. So that's our joist there. This small area where they meet, this contact area, which we'll highlight in red, is where the bearing stress is. So remember, bearing stress is just where there's contact between two surfaces. Um, direct stress from contact between two surfaces. And it's actually quite a complex stress distribution. So, um, but it often rarely governs in structural engineering. If you get into soils, yeah, that's bearing stress is a big consideration, particularly for shallow foundations. Um, but again, it's it's an indeterminate problem. You need to understand the deformation of the material in this small section that requires a lot of analysis, and it's often not worth our time. And we can still design a safe structure without it. So for bearing stress, it just equals our load over the airing of our bearing, and so will be AB over here. So that's one indication, as one example of it where you've got floor joists supported on top of each other. Another is bearing of a bolt against a plate. Bearing of bolt in a hole in a plate. So say we've got, this hole here, there's a plate, and we'll draw the bolt or the dowel, the pin, over here. And it's just getting, it's pressing up against it this way. So what does that look like? Well, let's take a section through here. So we've got our cutaway. Here, so that's our cutaway of our plate. And then we'll separate out our bolt, and we'll put our bolt over here in red. So over here, and that's our bolt. Cool. So again, much like the bearing stress between the joists, this is a really challenging analytical problem because there's nothing to say that every point of the surface is going to contact the inside at the same time. So as engineers, we will simplify where we can still get away and still have a safe, product. And product in this case for us are structures. So what we do is we project the area that the bolt will bear against. And so it will have, and this is our bearing area here, our projected area. It's going to have height T and width D. So same width as the bolt. So here, bearing is just going to be P over T times D of the bolt. And those are really our two main, very common cases for bearing stress. With both of them, we essentially use an average stress, and it's a reasonable approximation for how often that bearing stress tends to govern something. So it's pretty good. And with that concludes our introduction into stresses.